Understanding drones, from hobby quadcopters to advanced military UAVs. Drones, also known as unmanned aerial vehicles, UAVs, have revolutionized industries ranging from photography to national defense. Their ability to operate without a pilot on board and execute complex tasks has made them indispensable tools. But how do drones work? This script dives into the fascinating mechanics and technologies behind drones, from the small quadcopters you see in parks to the highly advanced military drones operating on global battlefields. At their core, drones rely on a combination of sensors, actuators, software, and communication systems. Let's break down the key components. Flight Controller, FC, the brain of the drone. It processes data from sensors and ensures stability during flight. Propulsion System, comprising motors, propellers, and batteries. This system generates lift and maneuverability. Sensors, accelerometers, gyroscopes, barometers, GPS modules, and cameras gather data to assist navigation and task execution. Remote control and communication. Hobby drones often use radio frequency, RF, signals for control, while advanced drones may use encrypted satellite links. Small drones and military drones share these basic principles, but differ vastly in complexity and purpose. Structure, typically lightweight, made from plastic or carbon fiber. Most have 4 rotors, quadcopters, for stability and ease of control. Control mechanism, controlled by a handheld remote or smartphone app. The user inputs commands that are transmitted to the flight controller. Sensors in action. Accelerometers and gyroscopes stabilize the drone. GPS allows for features like waypoint navigation and return-to-home functionality. Battery-powered flight. Hobby drones use rechargeable lithium polymer, LiPo, batteries, which typically provide 10 to 30 minutes of flight time. Applications. Popular for recreational use, photography, videography, and basic surveying tasks. Design. Larger, more durable frames with redundancy in systems, egg, dual GPS, backup batteries. Enhanced sensors, equipped with advanced cameras, LiDAR, thermal imaging, and multispectral sensors. Autonomy. Many can execute pre-programmed missions using artificial intelligence, AI, and advanced navigation algorithms. Connectivity. Operates through robust communication systems like 4G/5G or satellite links for long-range control. Applications. Used in agriculture, infrastructure inspection, logistics, disaster response, and environmental monitoring. Sophisticated design. Built for stealth, endurance, and high performance. Materials often include radar-absorbent composites. Power systems. Many use jet engines or advanced hybrid systems, allowing for extended missions and higher altitudes. High-tech sensors and payloads. Military drones are equipped with cutting-edge technologies. Electro-optical/infrared, EO/IR, cameras. Synthetic aperture radar, SAR. Signal intelligence, SIGINT, systems. Weapons payloads, EGD, missiles, and bombs. Autonomy and AI. Some military drones, like the MQ-9 Reaper, use onboard AI to assist in target identification and decision-making. Communication. Encrypted satellite links ensure secure control and real-time data transmission over thousands of miles. Applications. Surveillance, reconnaissance, combat operations, and intelligence gathering. Examples include MQ-9 Reaper, a hunter-killer drone used for precision strikes. Global Hawk high-altitude surveillance capable of covering vast areas. Switchblade drones, small, portable kamikaze drones for targeted strikes. While drones offer immense capabilities, they also face challenges. Battery life and range. Small drones are limited by battery technology, while larger drones require sophisticated energy systems. Regulation. Airspace management and privacy concerns are significant hurdles. Countermeasures. Military drones must contend with anti-drone technologies, including jamming and physical interception. As technology evolves, drones are becoming smarter. Advances in AI will enable even greater autonomy and efficiency. More versatile. Applications like urban air mobility, egged drone taxis are on the horizon. Environmentally friendly, solar-powered, and hydrogen-fueled drones are under development for sustainable operations. From hobbyists capturing stunning aerial shots to military forces conducting critical operations, drones have reshaped the modern world. Understanding how they work highlights the ingenuity behind these flying marvels and opens the door to their limitless potential in the future. Whether you're piloting a small quadcopter or marveling at the capabilities of a military UAV, drones are a testament to the intersection of engineering, technology, and imagination.